Welcome. The floor is now yours.
Great, thanks, Clinton, and thank you everybody for taking some time out of your day to come listen to this webinar. And I'm hopefully going to describe what I believe to be one of the more exciting features to be recently announced for DynamoDB, which is DynamoDB Streams. And we'll talk a little bit about how this enables some of the event-driven computing workflows that some of our customers have been asking for. So as part of this presentation today, hopefully we'll ask, we're going to answer a couple of questions. It looks like our font didn't really translate too well here. But the idea here is, what are DynamoDB Streams? And we'll talk a little bit about this. So we'll talk about some of the use cases for streams, and we'll talk about some of the design patterns there. And at the end of the presentation, hopefully you'll walk away with an understanding of why we've done this and why DynamoDB Streams is a pretty valuable piece of technology for you and your workflows. So first off, let's talk a little bit about a high level from what are DynamoDB Streams, and what they come down to is a time-ordered and partitioned change log that scales right along with your table. It provides a stream of updates to the table, including inserts, deletes, and updates. And it is guaranteed to be delivered only once into the stream. What this means is that for every update or insert to your DynamoDB table, you will see only one entry in the stream that represents the changes that were made to the item for that particular operation. These are going to be strictly time-ordered as well. So what that represents is a idempotent change log that can be replayed over and over again from any point in the stream to the end and maintain a very consistent view of data. And why this is important, we'll get into in some of the use cases and some of the reasons why we've done this. But we've also provided a library and some application implementations to support streams, and this is called the Kinesis Client Library. You can access the streams using this library. You can access these streams with AWS Lambda, which is an event-driven code framework, as well as directly through a low-level API if you want to write your own applications as well. So you can query a variety of dimensions of data off the stream, and we'll talk about what those are in detail later in the presentation. So first, let's get into what are the use cases for DynamoDB Streams. Again, we're running into some font issues here, so I apologize on my screen. Some of these fonts are rather dark. Hopefully they're showing up a little better for you, but if not, I'll fill in the gaps. So the idea here and the really primary use case for streams came out of some of our customers who really requested the need to do cross-region replication. And this was for a variety of use cases, but the idea was that we needed to get data into multiple regions around the world to support either geographical proximity of user base to the data, or even satisfy compliance or regulatory requirements that these customers had in their internal IT processes that need to be able to provide disaster recovery and meet those compliance requirements through separation of geographical space on data. So this cross-regional replication was one of the first use cases that we enabled with streams. And, the idea is pretty simple. Updates come in against the stream. We have a cross-regional replication library that we've implemented that will push those updates out to the other regions. Now, you might ask, okay, I could have done this by myself, but the idea here is that we've given you a library that does the bootstrapping, manages all of the workers and the threading and scaling of that effort across multiple shards. So as your workload and transaction load against your DynamoDB table increases and you increase the capacity of that table, the replication library underneath will scale the number of workers to accommodate that. Does all the load balancing, and then a critical function in any kind of replication is actually checkpointing of the stream records. So it actually creates a couple of tables of its own, some management tables that it maintains the positioning within the stream, so it knows what it's processed, what's been replicated, and if the process were to fail, where can it restart from. So that's a pretty important process or workflow when you're doing this type of replication. So the way the library works at its core is fairly straightforward. It will go ahead and fire up, as it initializes, a processing thread for each one of the shards in the stream. These shards represent the same kind of partitioning strategy that we have with DynamoDB. So we're going to spread the key space across shard instances, and then we'll process those updates on each item through these workers. So the updates come into the table, and I'm losing my arrows here in the font translation, I believe. Nope, there we go. And they'll hit those the DynamoDB stream, at which point the record processors in your KCL app or your Kinesis Client Library application will pull those records across and push those out to another region. As your table capacity increases, the Kinesis Client Library enabled application will actually scale the number of processing threads. So as we add shards into the DynamoDB stream, we will see additional workers pop in your Kinesis applications. So this is all handled underneath the covers for you when you use the KCL library, which is a pretty nice feature of the library. So we want to look at how do we consume this. It's a fairly straightforward example. I'm not going to break down all of the code for you. The full code for this is available online. If you go to the AWS docs for DynamoDB Streams, there's several sample applications that are available for you and how to use a KCL-enabled application or even direct API access as well. But the idea here is that you're going to configure a couple of client adapters, one for the DynamoDB stream and one for DynamoDB itself. And the reason I need both of these is because I need to read the stream records and I need to create my management tables. As we talked about, the KCL library will actually create a couple of tables within DynamoDB to use to manage the checkpointing and the workflow of processing that stream. So it basically maintains a current sequence count across the records that it's processing for each shard. We will configure a Kinesis client library configuration, which includes the stream ID that we want to read from, as well as a set of credentials that we'll use to read from it, the depth of the queue that we'll read records out of, and then where do we want to start. So you'll notice this trim horizon position in stream. Programmers always like to have fancy names. Trim horizon is really just the oldest record. It's where things start falling off the queue. The stream is about 24 hours of depth on the update stream, so that trim horizon is really that oldest record. You'll also see options like latest, which would be newest record, and you can also start at a particular sequence number or immediately after that sequence number. So those are the options for where we want to start reading the stream. And we just pass that all up into a worker, which is a Kinesis client library construct. We give it a record processor factory, and that's what's actually going to do the record processing. Once we start that thread, it'll launch a record processor for each one of those shards and start reading the records from the stream. Now, that record processor is a pretty straightforward implementation. What you're going to look like, something like this. You'll have a couple of, you're basically implementing an interface, a standard interface called iRecord processor. There's a couple of workflow methods in there you can override, the most important one of which is the process records. There's also methods for pre-processing and post-processing, basically start, stop, how do I set up my stream processor, and how do I tear it down, and then how do I process records. And you'll notice in this main loop here, you're just going to iterate through the records and basically parse the operation, and you can perform any number of operations inside this code. So you can imagine this opens up a wide variety of use cases that you can leverage using streams. One of those would be the possibility of doing triggers, right? Triggers can be executed by your KCL application. They can also be executed by Lambda functions. Lambda functions are nice. They don't require any infrastructure to be deployed, and they get called on the stream as stream records appear. So you'll get a Lambda function called once for every record that hits a stream, and those functions will retry if they don't complete. They'll retry until the data actually expires in the queue. So if you have problems with limits or whatnot, those can be those Lambda functions will automatically retry. And this is what those look like. So you'll have a user application pushing data into your DynamoDB table. Those updates, inserts, and changes to those items get pushed out into the stream, and then it's a standard Lambda invocation. You'll call the function, you give it an execution role, In this particular example, it's a very simple hello world application. As you can see, very similar to the iRecord processor interface in the Java implementation we just saw. You're going to iterate through or parse the record, and you can do anything you want with it. In this particular case, we're simply logging that information out to the Lambda console. But you can imagine that you can actually do many things, and some of those things that are rather interesting are things like aggregations. We can do on-the-fly aggregations using Lambda. You can also use your KCL application for this, but you can basically operate a Lambda function as a trigger that will run that aggregation. It can also rotate data. For example, if I had a document structure that was being inserted in our primary table, but I wanted to enable rich query functionality on a property of that document, which maybe DynamoDB doesn't support today, I can actually strip those properties out and create a new table in DynamoDB that is queryable, and in essence enable that rich query capability on nested properties in JSON documents, which is rather interesting. The other thing we can do is on-the-fly aggregations and change notification. We can let people know when certain items are modified. We can process those values and put those into external systems. In some cases, we might want to create caches or indexes on our data, and we can maintain those caches and indexes using those Lambda functions. So you can interface with additional AWS services such as Elasticache or Cloud Search. You can also integrate with any roll your own type of service deployed in EC2 or external data centers as well. Lambda functions are simply Java code that can execute without having to be deployed on an instance. They're actually Java and Node.js today, I believe, are the two platforms supported. So let's take all this together and look at how it works in a real application. So let's take real-time voting as an application. We have a lot of websites like to maintain real-time voting infrastructure for various reasons, and some of the requirements that we'll see. Oh, we're not getting our fonts here. This is not good. All right. I don't know why the font color changed. Anyways, the requirements for real-time voting would be we want our voters to vote only once. We want to support real-time aggregations on our voting data. We would like to have our users be able to scale the election to any size. So these are some of the base requirements we're looking at for a voting implementation. And I apologize. I'm going to actually have to switch to my backup deck here, which should be able to broadcast the fonts correctly. So our chart, and I apologize for this. All right, are we seeing the real-time voting requirements for voting now? Can I get verification? Clinton, are you seeing this? I can't, I don't have chat up. I need to get verbal verification. Are you guys seeing my screen? Okay. All right, so in our real-time voting application, we have these requirements for voting. We want our users to vote only once. We want no changing of these votes to occur. So when a user does try to attempt to vote a second time, we want that to be automatically rejected. We want real-time aggregation of these votes across candidates, and we want some voter analytics, right, on what kind of demographics, right? People like to report on these things on various types of elections. So we're assuming this is a public election we're managing. So in our initial implementation of this real-time voting architecture, we might say, great, I'll just create a nice voting application here. Voters are going to come in, they'll register with the app, they'll vote, they'll push their votes out to a raw votes table, and at the same time, we'll go ahead and do the aggregation. Right, so I'm doing all this in the application layer. And this will work to a certain extent, but what we usually see in elections are things like this, where we have a scaling bottleneck. Maybe we have two very popular candidates. If I'm starting to spread votes on my raw votes table, and I'm aggregating across candidates into a second table, what's going to end up happening is what we call a classic hotkey. So DynamoDB will spread data across partitions as any NoSQL database will. using a key value. If two candidates, which really are those keys, start achieving a lot of votes, then the aggregation is going to occur on a very, very narrow selection of nodes in my database. That's not good. So what we're going to end up doing is we're going to say we're going to manually shard these candidates, and we'll add a random value every now and then whenever I update a candidate. This could be anywhere from 1 to 1,000 at the end of the candidate's name. This gives me 1,000 keys that I'm updating, which spreads my load much more evenly and makes me scale, but it also introduces the complexity of having to aggregate all of these randomly sharded votes every now and then through a periodic process and pushing those into a sum table. So this could work. And this is the way we would have had to approach this problem prior to streams. The problem here is we get correctness in voting because I can update the DynamoDB table, and we can control conditional rights to the DynamoDB table and prevent people from voting twice. This is no problem. We increment the candidate counters, and we have our summary process that does our aggregation, and this is all nice. But do I really get correctness in aggregation? If the process were to ever fail that does that aggregation, if it's not checkpointing and managing itself, we could end up with some really screwy results here in our aggregation. We don't like that. So let's see how we might do this with streams, right? So it's much more improved architecture. In this particular architecture now, we have voters come into the voting app. They push those updates right to the raw votes table, okay? This handles any scale of election, right? Because the voter ID becomes the shard key. It shards across any number of partitions. DynamoDB scales to any amount of capacity. I can scale to any size of any election. The table itself handles all the dedupe. Vote only once, no changing votes. That's a conditional right on DynamoDB. And then we go ahead and we push those updates out via the DynamoDB stream to a Kinesis client library enabled app. This handles all of your fault tolerance, checkpointing, scale, takes care of everything, so that if you're processing that stream and you were to actually lose that application instance, you're not going to, when it comes back online, if you were to restart the instance, your aggregation will be consistent. At the same time, it can also push the data out into data stores like Redshift or even EMR for doing your demographic ad hoc queries for demographic reporting. Excuse me. So that in the end, what you get is real-time voter analytics, real-time statistics. It's highly reliable, it's consistent, and it's maintained by this Kinesis-enabled application that's using the DynamoDB stream, so it's controlled. And what we're having now is real-time analytics with streams, and this is a good use case for this. Basically, we're aggregating data in memory, flushing periodically, and we can use the DynamoDB streams to enable this kind of real-time aggregation and analytics function. So let's take a look at the kind of data that we're going to get from the stream when we go and query it. So I mentioned that every change to the table gets pushed into the stream, and you'll see what you're going to see on the stream are the actual values post-update or pre-update. Now, these are the dimensions. We'll talk a little bit about dimensions later, but what you're always going to see is the actual value of the item after the operation was applied. And the reason for this, that you'll never see, like if these were numeric values, you'll never see like an add 10, right, where we can increment values in DynamoDB, but that's not going to help you very much if I need to replay a stream and get consistent data, because adding to a value that's already been added to is not going to give you a consistent result. So what you'll see in the stream is the actual value. So even though my operation might have been an add 10, what you'll see is update and this value that it was. Now, as far as dimensions, you can see the old image before the update. You can see the new image after the update. You could see both. So these are the types of streams that you're going to create when you define the table. You can define an old image stream, a new image stream, an old and new image stream, and a keys-only stream. So if you're only interested in which items have been updated, you don't really care what was updated, then you can look at keys-only. So some flexibility in the types of streams that you can create and the dimensions that you can analyze. So just kind of reviewing some of the summary of the conversation, we'll talk about some of the basic streams, characteristics. As we mentioned, with DynamoDB Streams, each item is guaranteed to appear exactly once and only once in the stream, and these records are strictly ordered by time, really ordered by item and time. So As we create shards on the stream, all updates to a particular item will be located on the same shard, and they will be ordered by time. What makes the stream and item potent, transaction log is when I replay all items from the stream across all entities in the database, or all shards, from a particular point to the end, and I will be guaranteed a consistent view of that data. Streams are always asynchronous. They're never going to block table updates. So if I insert a record into a table, it will hit the stream asynchronously. So the write will be acknowledged before the data actually hits the stream. Streams are very durable and highly available. They're automatically replicated across multiple AZs. This is not something that you have to manage. It's managed for you. And all you have to do is turn them on. So you just simply enable the stream and off you go. Elasticity, these will adjust to your table throughput. Again, not something you need to concern yourself with. When I define a table with the stream enabled, it will automatically match the write capacity of that table. You don't need to adjust independently the throughput of the stream versus the throughput of the table. And they're designed for sub 1 second latency. So the idea is that from the time that the update hits the table to the time that it can be read from the stream, to the end user, to the client reader, is less than 1 second. As far as durability goes, items will remain in the stream for 24 hours. Okay, so they will appear only once. They can be read multiple times. They can be read anytime during the 24-hour period. This is why it's important when you're doing any kind of replication application to actually do that checkpointing process, and one of the reasons we give you the Kinesis client library to be able to manage that process for you. How much does it cost? It's free to turn it on. First 2.5 million reads per month are free. So you can see you support quite a few workloads just right there out of the box. And then after that, it's only 20 cents per million reads. So it's quite cost-effective solution for being able to replicate your DynamoDB data, or even rotate it into additional views, push it into cache, do indexing, whatnot. Some of the customers and what they're saying, we've got Mapbox. These guys were one of the guys that helped us drive the implementation. They're looking at needing to move data across regions to be able to get their data closer to their customers, right? So they're trying to decrease the latency of their customer queries, and really the DynamoDB Streams was critical for them, and they're one of the core customers for cross-region replication. Tokyo Hands, these guys do augment the point of sale systems. They do a lot of users also bot type of analysis on your clickstream, and they're using DynamoDB triggers to do all kinds of workflows at the point of sale for a lot of their customers, which is very valuable for them. So great use case examples for both cross-region replication as well as triggers. And there's hundreds of other customers as well using this at very, very large scale. For developers out there, we have a local version of DynamoDB, so you can actually install this on your desktop, get started developing, testing, support streams. So you can actually implement your application completely with a local version of Dynamo, and then move those table definitions and provision those tables up in AWS and move that application up there so you can develop offline. And some of the things we've talked about today, the cross-region replication app, and as well as the library, but these exist in two forms. So the library exists for you to build your own applications for doing replication off of DynamoDB Stream, and we also have an app which uses the application, which is a console application that you can use to deploy and manage that replication framework if you don't want to implement the application as well. So those URLs are both available in the presentation. Excuse me. And I think that's about all I have today. I appreciate your time, and I'm sorry for some of the technical difficulties in the font coloration. The version that you'll have available, I'm sure, will have corrections.